Hello everyone, and today we'll be talking about on-prem data centers as of private clouds compared to public clouds. And the thing here is that what we are going to talk today is what is a cloud, what lessons we can learn from public clouds, what technologies, consideration, and some bets that we could consider to create a private cloud that works as well as a public cloud, some conclusion, and then we'll go into the Q&A session. So about me, I have been working in the Linux space for quite some time, and also with the public clouds more than, well, roughly 15 years at this point. And I am also an AWS and Google certified architect. So I have a fairly good experience with both those clouds as well as other clouds, but I'm not certified for the others. Currently, I do work for SREday as a solution architect, which means that I help customers or partners to work with our technologies and more in general with those kind of open source technologies as well. So let's start from the very basic. What is a cloud? So I did what everyone does, go to Wikipedia, and Wikipedia says that a cloud computing is the on-demand availability of computing system resources, especially storage and computing power, without direct active management by the user. I don't really agree with this definition. I don't think that this definition solves the real question of what is a cloud, because this is a good definition of a public cloud, maybe, but probably not even that. And I think that the better definition is actually that a cloud is a business model where one party rents to a second party compute system resources, especially storage and cloud computing, with the smallest granularity possible. Because I think this is way more clear. First of all, because we have two parties. Those can be two parties of the same organization, for the private cloud maybe, or two parties that are two different organizations if it's a public cloud kind of scenario. And the real point is that it's a business model, and the point is having a very small granularity. So what we have seen over time is that we measure time on clouds in very specific ways. We used to do it in months. So you used to get a VPS for 1 month, 2 months, whatever it was. And now we have to pay lambdas, for instance, on milliseconds, increases. And also compute resources have moved from full CPUs, like socket CPUs, to fractional vCPUs, which basically means that you get millicores out of someone else's system. And the point of measuring things so precisely means that we can then go back to say exactly how much does an application or a service cost. Because the risk with the old model was that the minimum amount I could buy was one socket for 1 month. And even if my application was not filling it, I was still going to pay for it. And very frequently, even though the payment was monthly, the contract was maybe 1 year or 5 years' time. So effectively, that meant that there was not that flexibility around those applications. So what lesson can we learn from those public clouds that have thrived for the last 15 years? The first point is the separation of concern. The standardization of the interface between the cloud or the platform and the workload is critical. All those companies, those hyperscalers, AWS, Google, Azure, and so on, have created a limited amount of services, and each one of those services has clear APIs that you can use. They don't have like a custom system, a custom service that they run for you, which was very frequent in private data centers, where basically an application developer was like, well, we need this odd thing, and an operation would find ways to run it and build it, maybe. We don't have those with hyperscalers because that obviously would not scale. So I think this is something we can really learn from the public clouds if we are going to implement a private cloud. The second aspect, and is linked to the first one, is the scalability. The scalability is expected to be on the workload side. So the application will need to be aware of the fact that pods can go down or VMs can go down. It will need to be aware that there might be more than one running at the same time. So global lock, it's not really that something that works on clouds. Well, in the past, it was very frequent to say, oh, the application will not care about those kind of things because the hardware will stay always on, or things like that. The third aspect is that the workload have an abstract concept of the physical architecture. And by this, I mean that in reality, you don't really know where your application is running. You know that maybe it's in a specific AWS zone or region, but where exactly? What is the server line? What is the server height that your application is running on? You have no idea. And a lot of times, like in AWS, you don't even know exactly where the data center is because they are very secretive about their data center locations. So you care that in a way it's running, let's say in Europe North 1. Where is that place? Who knows? Who cares? There is also some consideration about business model. Obviously, public clouds have functioning business models. They are usually the highest performing business unit within their company. So that means that they have good business models, while we know that usually IT departments, internal IT departments, have no business model to the point that they are only seen as a cost to the business. So first of all, by standardizing the interface between the infrastructure and the workload, we can actually charge or fake charge. It's not important if it's like a credit card charge or an accounting charge, but at least we know that that specific application was costing X. The second aspect is to bill back those amounts, because the fact that we can now bill back to the business unit that is running the application and therefore getting value out of that application, the cost of the infrastructure and the management of that application, that means that first of all, the management has a better idea on what exactly is the cost benefit of that service, because there is a clear cost now. And second, the IT department is not the sinking cost part of the company, where basically if you just look at the standard accounting of an IT department, it's down of like 10 million a year. Why? Well, because it's only getting the cost and not the revenue side of the business. And the third aspect is that it's very important to keep costs down. Those hyperscalers have been able to scale and make money based on the fact that they over-optimize every single aspect of what they deliver. They don't have 50 people on call just because. They have a very limited amount of people on call. Those people and the application that they run or the system that they run tend to be all very similar, so that very small amount of people on call are able to operate on every single system that they have to, and those kind of things. And those are critical aspects. If we want to have IT departments that are in the green, we will need to figure out ways to be very optimized and conscious about the expenses that we are going to incur. And the third aspect is maintain control. So historically speaking, companies were very happy to buy from some vendor a bunch of software, which is not a problem by itself at day zero. The problem is 10 years after, what happens? Because very often costs go up, the licensing costs go up. Maybe we are not reporting properly, so we are maybe paying for licenses that we are not really using. Maybe due to the license policy that that specific software has, you cannot reuse maybe the same license for a different application if you decommission the first one. So based on many aspects, it's very risky to put in your organization proprietary software that has those kind of license models. I think that there is also a very important point about being very aware on when you are buying software and you are building software. And buy, I use a very wide definition of buy, is like even if you are just downloading from GitHub a repository, that is buying software, because it's software that someone has developed and you are using it. Build software is when you build your own software internally, so you have the know-how, and obviously you also have the cost of development of that software. The big advantage of building software is that you can maintain it over time. So you have probably seen all those images of your stack and the very small piece of software that someone maintained somewhere in the world, but you have no idea who that person is and if they will continue to maintain that part of your stack. So building internally allows you to have control over that. Obviously, it does have cost. So you have to balance the two things around. And be aware of lock-ins. I think this is the most important part. There is no issue using software that gives you lock-in. But the important part is that when you are doing a decision, a software decision, you are aware of which lock-ins you are getting. And the way I think about lock-ins is with the definition that I use, which is a lock-in is the product between the probability that a component will require substitution during the life cycle of the solution and the total cost in case that occurs. So effectively, if you think about lock-ins in this way, everything is a lock-in. The Linux kernel is a lock-in because you will depend on the Linux kernel APIs to be there, whatever you are doing. If you are obviously choosing Linux, or the Windows APIs if you are going in that direction, but still those are lock-ins. How probable is that either Linux or Windows will disappear in the next 5 years? I would say not very probable. So even though that is a lock-in, it's a lock-in that we have evaluated and we have estimated, and we are okay accepting that. And hopefully, if you are a little bit worried about some lock-ins decisions that you are making, you should have an exit plan. Because if you are already aware of something that you are buying that might be a little bit problematic there, having an exit plan can help you decrease that cost or risk of exit. So some technologies considerations that I think today make sense to do if you are today designing a private cloud kind of scenario, and some bets that I think would be reasonable bets in today's world. So obviously a consideration first, which is case, keep it simple, reduce the complexity of your system at a minimum. That probably should have been true also 20 years ago, but today we have seen that it's possible to do this, so let's do this. You should not have anything too complex from day zero. It might get more complex over time, but try to keep it as simple as possible. The second aspect is to prefer build time complexity over runtime complexity. And I know that this is fairly controversial because everyone is like, well, if we do things that are more complex today, we are going to pay today the price. While if today is easy, over time we will figure it out. Well, the reality is that you will not figure it out, and complexity will just add up. So, for instance, for this reason, I really like compiled languages, and even more stuff like Go, which is creates a static bundle with all libraries included, which means that at runtime, it's going to be very easy to execute because you will always have exactly the right libraries. While obviously at compile time, it's a little bit more complex. But you can apply exactly the same reasoning to any other decision, either at software level or architectural level. And the third aspect is to minimize the amount of services that you are going to give to your user. So if you can start with one or two storage solutions, like a block storage, file storage, object storage solution, and one compute way, which could be container, could be function, it's not important, but just one computer type and a couple of storage types, and that's it. And if your user will be okay running on that things, then it will become much easier over time for you to run your systems. If at day zero you have 200 different services, then, well, you will have a lot of complexity to handle over time. A bet that I think today it's a reasonable one is containers. I think that today majority of application can run in containers. There are obviously some asterisks here and there, but also container can be flexible enough to be as small as a single function and as big as very big systems. So effectively, a container, I think it's a fairly good way of handling the compute power. I would suggest using a Kubernetes distribution. Kubernetes today is becoming kind of the standard, I think. I think that in 5 years' time, it will be like the Unix APIs. It's like everything is running on that Kubernetes language. Maybe it's not running Kubernetes itself. Maybe it's running some different flavor, but still it's understanding what a deployment is, what is a service, and those kind of things. There are today two main options. You either do a DIY community, upstream, open source, call it whatever you want, and then you have to manage it. Or you can go with the commercial option, which is buy it from somewhere. I think both can be valid. It's really based on what your experience is, what your team experience is, how big is your team, and so on. But if you're going commercial, I think that it needs to be worth it. So to be worth it, it needs to be fully open source, because the risk is that if it's not fully open source, over time you might have more complexity. If it's fully open source, worst case scenario, you are going to support it yourself. So you have a good exit strategy, which will decrease your lock-in. Second aspect has to be a trustworthy company. And by trustworthy company, I mean whatever company you are going to trust, which seems obvious, but a lot of people buy databases, for instance, from companies that they don't really trust or like. And it's like, I understand that at this point you are so used to that specific database that you have to, but if you are starting something new, you should really start with a company that you trust. And the third aspect is that it needs to have a long track record of behaving properly, and properly, same definition as before, based on your definition of properly, whatever works for you. And I think that the last aspect is that it has to be an upstream developer as well, because otherwise what you are really buying here, it's open source. So, okay, you are buying probably some kind of support and some tooling around it, and okay. But if it's a very small shop, maybe that has 10 people working in the company and you have 50 people in the department, well, at that point, maybe it's cheaper for you to do it yourself than relying on that third party. I think that the third aspect that is critical in any kind of system today is automation. You have to automate everything. Otherwise, that reduce cost that the clouds are very good at, well, you will not be that good at. So I would suggest using an immutable approach to infrastructure. There are different kind of immutable approaches to infrastructures. You have obviously to pick the one that works better for you. But generally speaking, immutability helps with simplifying the processes. And it's also that idea of moving complexity at build time compared to runtime, because at runtime, something that is immutable is way easier to handle. It's a little bit more complex at build time because you have to build that image. But still, I think it does help in that way. The second aspect is version everything. So version your infrastructure, GitOps is one approach. There are other approaches as well, but be sure that you are always able to roll back to any known state and also be able to say exactly what was rolled out in production at any given time. The third aspect is to automate the whole process. It's very easy to automate parts of processes, but if you don't automate a process end-to-end, you will not get that efficiency advantage that the automation should be about. So try to automate the whole process since the very beginning. So wrapping up and putting everything together, there are three aspects, three layers of this private cloud cake that you should consider: the infrastructure, API, and workload. As for the infrastructure, I would really suggest you to create and or architect your system to have multiple data centers, multiple clusters in those data centers, but hide all those complexity from your users being the workload developers. They should not be aware of what exactly there is below them, because if they start to create specific code for running on certain things, then the complexity of the whole system will very easily increase. The second aspect is deploy container platform that is bare metal. I know that bare metal Kubernetes is more complex than non-bare metal Kubernetes, but if you go bare metal, you are moving that complexity from runtime to build time. It's more complex to build it, but you will have one less layer to handle, because if it's not bare metal, that means that you have a virtualizer layer and you are building on top of it, which means that you have two layers instead of one. And the third aspect is that you should, I think, use a way to abstract the cluster. So you should not expose the idea of a cluster to your users. You should expose something that is higher level. So Open Cluster Management, for instance, is an open source project that does exactly this. There are a bunch of others. Find the one that works better for you, obviously. And also, as said before, automate everything. It really helps. As for the APIs, define discrete regions, not based on physical situations, but on legal situations. So, for instance, Europe has a very, legal specialities, so GDPRs, for instance, and all the other stuff. So you might want to have a EU region. US also has different kind of law framework, legal frameworks. UK has different legal frameworks. So those kind of regions, I think, make sense because they make business sense, not technical sense. The second is standardize on Kubernetes APIs. And by this, I mean, think about pods, services, those kind of things. Today, those are going to be implemented by the Kube API server, maybe tomorrow by something else, but still that kind of abstraction seems to be very useful and probably will be the one that will be supported over time. The third aspect is start to provide as small number of APIs as possible. So some ideas would be obviously registry storage, object storage, some objects such as pods deployment, PVs, PVCs, and so on. But try to keep the number as small as possible to be useful, obviously, to your customer, but to be always also sure that you are going to be able to manage this over time. Because whatever API you are providing today, you will be providing it for the whole history of your platform. And then over time, you can add more. It's fine. As long as you know that if you are adding, let's say, a PGSQL service for your users, you already have 10 users, 50 users, or whatever number of users that are already using that database. You have already talked with them. If you are going to provide that kind of database as a service, they are going to move to your service, then it does make sense to do so. But be sure to add services only when they are really needed or would be used. And talking about the workload, the first aspect is to create a very simple user experience. Could be a UI, a web UI, CLI, whatever works in your organization to create, update, and delete workloads. And your users will be using that UI or that UX. They will not be connecting to your systems because your systems are your systems. They only care about their workloads, which should be abstract. The second aspect is store those objects versioned always. And the reason is that if after a while they complain, oh, but you broke something, you are able to say, actually not. That happened, and therefore everything broke. And I would say require application to be resilient to restarts, replication, and a lot of other complexity that can happen in those environments. I would say maybe you will need to create an opt-out system so that some workloads have more additional guarantees, but if you are able to avoid that, that is even better. So with this, thank you. And if there are questions?
A quick one from me. What would you recommend for implementing PVs in the bare metal scenario?
I think there are many options. So there are open source options such as Ceph, for instance. There are more proprietary options. There are Sun as well that do those kind of things. It really depends on what is your situation, what is your data center, and your requirements.
Great, thank you. I have a similar question, but it's on the case distribution. Which case distribution would you recommend for the minimum overhead management? For example, I want to run my own cluster on a bare metal server, and I have two options, let's say the standard Kubernetes installation or something like micro-K8s. So how would you go about this situation? Would you recommend micro-K8s or would you say just go with standard? What's your approach here?
So if you are going with the open source version, I would go with the standard one. When I say multiple clusters, I mean like maybe if you have 100 machines, don't put 100 machines on one cluster, because if you have to do an update on that cluster, you're risking your whole computing power. But maybe do 3 cluster, 5 cluster over 100 machines. So we are not in the micro Kubernetes kind of area. We are still in the full Kubernetes, but try not to have 5,000 machines in a single cluster. That creates different kind of issues.
Got it. Thank you. And another question which is also similar is, do you have any suggestion for alternate to Amazon S3 but open source?
Yes, there are many. Many storage solutions also provide that kind of APIs. And also there is Mini.io, for instance, which is an open source project that does the same thing. And at this point, the S3 APIs have become kind of a standard for object storage. So you can find them pretty much in every storage solution.
Perfect. Thank you.
All right. One more.
Hi, thank you for the presentation. So I have a question, something that I agree with, that you just talk about the KISS philosophy, but that it's something that I struggle every single day having those discussions, and it's around some of the push that some of the cloud providers with the this is managed, this is easier. So I was recently having a discussion with some other engineers, and what started as a feature in a service evolved into but provider X provides X as a managed service, but in reality it was like 3 services that we'll have to launch, that we'll have to manage, and over time adding more stuff that we actually didn't need but was already there because we're part of the managed service. So do you have any suggestions on how to navigate these discussions about like, we could do just this, but because this is a managed service, probably it's a good idea to just go there because the provider will manage that, but we all know that it's not really like that, right?
At that point, I would make a conversation about lock-ins. So what is the lock-in you are taking there? Obviously, you will always take lock-ins, but the real question is, are you aware that you are doing it? And with cloud services, it's very easy to forget that you are getting a lock-in. So I would try to focus exactly what is the lock-in we are taking on, and is that what we want to do or not.